Hi, my name is Joe Whalen. I'm a systems engineer with NetApp. Today we're going to be looking at a SAN demonstration for block protocols running on Clustered ONTAP 8.2. Some capabilities we're going to demonstrate today are setting up a storage virtual machine and presenting LUNs to a Windows 2012 host. We're going to be using OnCommand System Manager and SnapDrive to achieve this. We're going to set up multipathing on a Windows 2012 server, and we're also going to be doing volume moves using data motion and understanding how that affects multipath behavior. Some advanced functionality is copy offload, logical block provisioning, and some space reclamation functions. We're seeing how that affects the SAN protocols. Our lab today is we're going to be RDPing into a jump host running Windows 2008. We'll also have a Windows 2012 server that we do the majority of our work on. That's all plugs into a demo network. We also have a 2-node data ONTAP cluster set up. We're running 5 vServers, and all of these vServers are connecting into a cluster 10 gig dedicated network on the back end. Okay, so let's get started. We're going to launch OnCommand System Manager. What we're going to do is we're going to create our first vServer for the Windows demo today. So we're going to go to the vServers tab. We're going to highlight the cluster and hit Create to create our vServer. vServer name for purposes of this demo is going to be vs_win. We're going to choose the Iscsi protocol. Security style for our LUN is always going to be Unix. We're going to choose our aggregate and hit Save and Continue. So now we're actually creating our lift configuration for this vServer. So we're creating a Iscsi lift. So you can see lifts per node we have set at 2. So we're giving the starting IP address of .132. So it'll create 132 and 133. Net mask is 24-bit, and our gateway is going to be 0.1. And we're going to hit Submit and Continue. We're going to review our lift configuration. So we have 132, 133 for node 1, and we're going to have 134 and 135 for 2. We're also going to change change over from E0E to E0C on those first interfaces. And that's just from our network folks who have our lab set up here that they made that recommendation. I'm going to submit and continue. So here we're setting up a VS admin account. So this will just be an administrative account for this particular vServer. It has no capabilities to enter into any other vServer within the cluster. And here we're setting up the management lift for this vServer. So we're going to give it an IP address of 192.168.0.131, again with a 24-bit subnet mask and a gateway of 0.1. And we'll again choose E0C as the home port for this lift. I'm going to submit and continue. We're going to verify all of our configuration information and hit OK. And you can see we successfully set up our first vServer, vs_win. Okay, so now we're going to go back into OnCommand System Manager. We're going to create a volume. So you can see we have our root volume that's created during creation of the vServer. So we're going to create one for a data volume. So we hit the Create button. Once we have the Volumes tab highlighted, we're going to call this Win1. You have to choose which aggregate it's going to belong. So we don't want to put it on AG0, which is for the root volume only. We're going to put it on AG1 that we created. We're going to check storage type of SAN. We're going to make it 5 gig and then provision it. And hit Create. So now we have a 5 gig volume. So we're going to minimize this, and we're going to do the rest of our work within the SnapDrive application. So again, this is run from the host that you're going to be presenting the LUN to. So first thing we're going to do is we're going to actually go into the transport settings, transport protocol settings. And we're going to verify that we're using HTTPS over 443 port. We're going to click on the disk section. And once that populates, we're going to right click and hit create disk. There we go. So that brings up the create disk wizard. We're going to click next off the home page. So we're going to enter our storage system that we just created the volume on. So it's 192.168.0.131. We're going to hit add. Now we see the one data volume that we created. We don't see that root volume. That's not going to be shown here. We're going to enter our LUN name. So we're just call something logical. So win1.lun. I'm going to hit next. It's a dedicated LUN. If this was any kind of like a Microsoft cluster, it would be shared, but this is going to be dedicated. We're going to accept the E drive. We're going to call it 4 gig LUN. We're going to choose our Microsoft Software Iscsi Initiator. So we're going to check that box. So currently there's no session that's established, so we have to do that now. So we're going to hit yes. You go next. You can see the storage system is .131. We're going to hit next. And now what we're doing is our source is .42. We're going to select the 132 target. Hit finish. And now we've established that session. So we're going to hit next. We're going to let it automatically create the iGroup for us instead of having to manually do it via OnCommand System Manager. And we're going to hit finish. You can see all the steps that it's doing for us. So this really just automates a lot of the functionality that we would have to manually go through a lot of steps, either via command line or OnCommand System Manager. SnapDrive just can really facilitate a lot of that for us. We would also have to go into Windows Disk Management, format the drive. It actually does all that for us and just gets it to a state where it's ready to start writing data to it. It's a real nice tool to have. And this will wrap up in a second, and we'll see that now we have an E drive all ready to go. Okay, so now what we're going to do is we set up one session, one Iscsi session. We're actually want to set up 3 additional sessions for all 4 lifts that are set up for that Iscsi vServer. So what we're going to do here is go into Iscsi Management, and we're going to add sessions. So we're in the Iscsi Session Wizard. We're going to go to the Management IP, which is .131, and hit Next. There we go. And you can see .132 is grayed out because we already have a session there, so that we chose .133, and we're going to hit Finish. And that establishes the second session, and what we can do is we can expand the target list and sessions, and you see a session 1 and a session 2. And now we're doing the same thing for the other 2 lifts. So we're going to go to Next, Management IP again, 192.168.0.131. Going to hit Next. Now we're going to do .134. And one more time, right click, establish session, next, 192.168.0.131. And choose the last session of 135, hit next, finish, and now we have all 4 sessions established for that vServer. Great. Okay, so we're going to look at some of the multipathing configurations. So we're going to go into Windows Disk Management. We're going to go to the E drive, which is the one that we just presented via SnapDrive. We're going to right-click on that and go to Properties and click on the Hardware tab. And what we'll see is a NetApp C-Mode LUN that's presented, a multipath disk. We're going to go to Properties for that. And then we're going to go to MPIO. And you can see the two active sessions that are established and optimized. And then you have the other two lifts that are unoptimized active paths. So we're going to cancel out of that. Cancel out of that. Now we're actually go up to the data OnTap Dsm, which gives you a little more granularity in looking at your multipathing options. And again, you can see the same thing, two active optimized paths and two active non-optimized paths. And if you scroll over, you can see 131 and the 132, which are on node 1, are the active optimized. So what we're going to do now is we're actually going to pop into OnCommand System Manager, and we're going to disable the two lifts that are on node 1. So the active optimized paths are no longer available, and we're going to see what that looks like. So we're going to go into that vServer. We're going to go to Network Interfaces and right-click and choose Disable. And again, we're going to do that for lift 1 and lift 2, which are both on node 1. And you can see the status change from enable to disable. Okay, we're going to refresh. Great, so lifts 1 and 2 are now both disabled. So now we are going to pop back into our data ONTAP Dsm. I'm going to refresh that view. And we're going to go back into, here we go, back into the DSM. It's refreshed. And you can see those two active optimized sessions are now gone. And we just see lifts 3 and 4 that are the two remaining active sessions, but they are non-optimized. And you can see here we can go right into that E drive. I just want to prove that we can create a file, we can save a file, we can write to it, no problem, even though we're going down a non-optimized path. So we'll just call it test. Let's open that up, just write test in there, save it, no problem. So we'll close out of that. So now let's go back into OnCommand System Manager. We're going to re-enable lifts 1 and 2 by right-clicking and just choosing Enable. Right-click on 1, choose Enable. We're going to refresh. You can see the status now change. So everything's enabled. And if we go back into the DSM, and again we'll refresh that view, we should see both active optimized paths back in there, along with the two active non-optimized paths, which we do. There you go. Okay, so now we're going to do a volume move and see what the effect is on the multipathing configuration on the host. So we're going to go into our vServer for Iscsi. We're going to go into volumes and work on our Win1 volume that the Iscsi LUN lives on. And we're going to do a move. And you can see currently it lives on node 1. We're going to move it to its new destination aggregate, which is node 2. And we're going to hit move and confirm the move. We're going to hit OK. And then what we can do is we can click right on the job ID, 481. And what we'll do is we'll keep hitting refresh and just check out how the status keeps changing of the job. So the current state is running. And this will take a couple minutes to complete. So now it's in progress, is transferring data. State is still running. So once it gets the data to where the majority of the data is transferred, then we will actually do a cutover phase, which is the final cutover, where it moves the volume. So we're going to keep hitting refresh here. So it's still transferring data in progress. State is still running. Okay, so now it's still state is running, but the progress has changed to cutover started. So this is really the last phase in the cutover process. Hit refresh again. And state is now a success, so it's complete. So what we're doing now is we're going to pop back into our DSM, and what you're going to see is that the active optimized paths, which were on 132 and 133, we're now going to refresh that view. And you'll see that the new optimized paths are on 134 and 135. There you go. Okay, so what we're going to do here, similar to creating this, but this time we're actually going to connect to a disk, meaning that we have a volume and a LUN already configured on the controller. So again, we're going to enter in our management IP address for our vServer. This is actually a different vServer, .136. So we're going to expand the volume, and you can see this volume has a LUN associated with it, Win2. So we're going to connect directly to that. Again, it's going to be a dedicated disk. It's not a shared clustered volume. We're going to choose the drive letter H. We're going to choose our Iscsi initiator. We're going to automatically create the I group, so the LUN masking does not need to be done at the controller level via OnCommand System Manager. And again, we're connecting to the LUN. SnapDrive just automates a lot of manual steps that you would take without the application. Great. And we're going to go in here and we have one more LUN that we're going to connect to. So we're going to go through the same process. We're going to right click on disk. We're going to hit connect disk. Brings up the wizard. Again, we enter the management IP address of 192.168.0.136. Add. So we're going to do the Win3 volume, the Win3 LUN. Hit next. It's a dedicated LUN. We're going to choose G as the drive letter for this. We're going to hit next. We'll choose the Iscsi software initiator. Next. We're going to automatically create the I group and click finish. And again, it automates all these steps for us. It's going to mount the LUN. And now we're going to have a G and an H drive. So we have Win1 that we created on the E drive, Win2 on H, and Win3 on G. Great. Okay, so on the G and the H drive, we've written 400 megs of data to each of these drives. What you will notice is the G drive has space allocation enabled, and the H drive, which is Win3, has space allocation disabled. So what that means is that drive G, Win2, will benefit from the space reclamation after we delete the file, where Win3 will not. So just to demonstrate that, we're going to go into the vServer that holds these LUNs. We're going to look at the LUNs, and you can see right now percent used, 42% for Win2 and 15% for Win3. Okay. So now we're going to go back into my computer and we're going to delete the 400 meg file from each drive. So we're deleted from G, which is the one with space allocation enabled. And we're deleted from H, which has space allocation disabled. And what you'll see is once we go back into OnCommand System Manager, you're going to see that only Win2 actually reclaims that space. And it usually takes somewhere up to a minute for us to actually see that space reclamation take place. So it's still at 42%. We're going to refresh. And there you go. Back down to 2%, and the space is reclaimed. Only on Win2 and not on Win3. Okay, so what we've done here is we've kicked off a PowerShell script to overwrite to the H drive. So basically we overwrote the amount of physical available space. So the LUN itself was thinly provisioned, but it actually ran out of space. So Windows 2012 will actually take that LUN offline. And you can see if we go into the event viewer that it basically exhausted the LUN, meaning that it just overwrote to the point where it just took it offline. It had no more available space. So you can see from OnCommand System Manager, the LUN itself is still active and online. So what we need to do is we actually need to grow the LUN out. So we're going to edit that LUN, and we're going to actually resize it. We're going to go to the Volumes tab. We're going to click on Win2, where that Win2 LUN resides. We're going to hit Resize on the volume. We're going to go Next. Right now it's at 600 meg. What we're going to do is we're going to increase that all the way up to 2 gig. We're going to hit Next. We're going to say the maximum size for that volume is going to be 3 gigs. We don't want it to exceed that. There's no snapshots on this, so we can hit Next. And it's summing up. We're going from 600 meg to 2 gigs with a max of 3 gigs. And we're going to hit Finish. And immediately that LUN, or that volume, has been resized. So now what we need to do on the host side is we actually need to bring that LUN back online. So the way we do that in Windows 2012 is we're going to go into Disk Part. We're going to list all the disks that are available. You can see disk 2 is offline. So we're going to select disk 2. Now that we know that LUN is good, we can comfortably bring that back online. We're basically going to clear out all the attributes. And we can exit out of that. We can see H is now back online. We're going to want to get rid of that file that's on there because that's probably junk at this point because it died while it was writing it. So we're going to want to delete that out. And last thing we're going to want to do also is go into the trash and actually empty out the recycle bin as well. And that's just a clean way of getting rid of any potentially corrupted data that resides on that LUN. There you go. And the last thing we're going to demonstrate today is we're going to copy a 900 meg file that we copied, that we generated to the H drive. We're going to copy that in Windows Explorer from H to G. And one thing we're going to notice is we're going to be able to actually offload that copy process so that it's actually not traverse the Ethernet connection, and it all happens at the array level. So we're going to bring up Task Manager, and you can see the amount of Ethernet traffic going on, which is very nominal. So we're going to go into the H drive. Trying to arrange the screen so we can see both. We're going to copy that 900 meg file, and we're going to copy it to G. I'm going to paste. And what you'll notice is the amount of Ethernet traffic really has not changed much. That's because the copy process is being offloaded and is being done at the array level. Very similar to some functionality that we have with our integration with VMware with VAAI, just offloading a lot of that workload to where it never comes off of the array. And just while that file copies, we can keep up Task Manager and just look at the amount of Ethernet traffic. Again, not really increasing much at all. You can see the whole time just the amount of Ethernet traffic has not really increased as we're finishing up here. And there you go, copy's complete. Okay, and that's going to do it for our demonstration of block level protocols in Clustered ONTAP 8.2. Thank you for your time today, and I hope this was useful for you, and we look forward to seeing you next time.